Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 17, in which I will solve some miscellaneous problems on independent events. Now we solve a problem. Problem is known as Huygens problem. Problem is A and B throw alternately with a pair of dice. A wins if he throws 6 before B throws 7, and B wins if he throws 7 before A throws 6. If A begins, find his chance of winning. Now we solve this. If 2 dice be thrown, then the sample space contains 36 number of elements. Sample space contains elements in the form of ordered pair 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, and ... and lastly ordered pair 6 6. Means 36 number of elements in sample space. If A throws 2 dice and he gets 6, means the sum of the components of the ordered pair be 6. That means in the first die he get 1, second die 5, means 1 plus 5 6. In the first die 2, in the second die 4, 2 plus 4 6. In the first die 3, in the second die 3, 3 plus 3 6. In the first die 4, in the second die 2, 4 plus 2 6. In the first die 5, in the second die 1, 5 plus 1 6. Therefore this event is denoted by E. Here each pair of elements is in the form that sum of the components of each pair be 6. Number of elements in the event E be 5. Therefore, probability of event E equal to NE by NS. Means number of elements in event, that is 5, and number of elements in sample space 36. 5 by 36. This means A wins if he throws 6. Means if in the first chance A gets this event, then probability of this event will be 5 by 36. Let it is denoted by a small p. Now probability that A will not win in a throw. That means probability of complement of event E, that is 1 minus PE. 1 minus PE means 1 minus 5 by 36, and this is 31 by 36. If B throws 2 dice and he gets 7, and let this event is denoted by F, then F will be 7. Means if he throws 2 dice, if in first die 1 appear, then in the second die 6 should appear. That means 1 6, 1 plus 6 7, 2 5, 2 plus 5 7, 3 4, 3 plus 4 7, 4 3, 4 plus 3 7, 5 2, 5 plus 2 7, 6 1, 6 plus 1 7. Means number of elements 1 2 3 4 5 6. Therefore, probability of event F will be number of elements in event F by number of elements in sample space. Means 6 by 36. That is 1 by 6. Now, if B throws 7, then he will win. And the event for B does not win will be F prime, and P F prime equal to 1 minus PF, means 1 minus PF means 1 by 6 equal to 5 by 6. Let this is equal to Q and this is equal to Q prime. Since given that A begins to throw, if A wins in first throw, then our problem will be solved. If A does not win in the first throw, then B will throw 2 dice, because here given that A and B throw alternately. And in the second throw, if B does not win, then in the third throw, A will throw 2 dice. And if he wins in the third throw, then our problem will be solved. That means if he wins in the first throw, our problem will be solved. If he wins in third throw, then our problem will be solved. If he does not win in the third throw, then B will throw 2 dice in fourth throw. If B will not win in the fourth throw, then A will throw 2 dice in fifth throw. If he wins in fifth throw, then our problem will be solved. And in this way, we may see that A can win if he throws 6 in the first, third, fifth, etc. throws. Now, the chance of winning of A equal to, if he wins in the first throw, chance means probability. If he wins in first throw, then this will be P. Or if he does not win in the first throw, means P prime. B will throw the dice, and if B will not win in the second throw, that is Q prime. Here we have taken multiply because throw of A and throw of B are independent events. So here multiply, intersection means multiply. And B will not win in the second throw, then A will throw the die, and if he wins in the third throw, then our problem will be solved. Or if A will not win in the third throw, that means in the first throw A will not win, in the second throw B will not win, in the third throw A will not win, in the fourth throw B will not win, in fifth throw A will win, and we proceed. This equal to P means 5 by 36. P prime means 31 by 36. Q prime means 5 by 6. P means 5 by 36 or plus P prime means 31 by 36, Q prime means 5 by 6, P prime means 31 by 36, Q prime means 5 by 6 and P means 5 by 36 and so on. If we take common 5 by 36, we will get 1 plus 31 multiply 5 by 36 multiply 6 plus, here we have taken 5 by 36 means 31 multiply 5 by 36 multiply 6 whole square and so on. The term under bracket is an infinite series which is in GP. Common ratio is less than 1. Therefore, we may write this equal to 5 by 36 and here common ratio is 31 multiply 5 by 36 multiply 6, that is 1 by 1 minus common ratio, means 1 by 1 minus 31 multiply 5 by 36 multiply 6 and this equal to 30 by 61. So our problem is solved. Now we solve problem number 2. Problem is A, B, C are 3 questions. For a student, the odds against solving them are 5 is to 2, 6 is to 5 and 2 is to 1 respectively. Find the probability that number 1, at least one question will be solved. Number 2, exactly 2 questions will be solved. Now we solve this. Firstly, we have to know what is odds against and also one term, odds in favor of event E. Since we know that odds in favor of event E equal to number of elements in E, event E, divided by number of elements of complement of E. If we divide both by ns, ne by ns by ne prime by ns equal to pe by pe prime. This is odds in favor of E. Pe by pe prime. Pe means probability of E. Odds against of E is number of elements in complement of E by number of elements in event E. If we divide both by ns, we get this is ne prime by ns equal to pe prime probability of E prime and here this is probability of E. Here we have given that to solve the first problem A, odds against B 5 is to 2. That means odds against means 5 is to 2. This is P A prime by P A implies that 5 plus 2 by 2 equal to P A prime plus P A by P A and P A prime plus P A is 1 by P A. This means P A equal to 2 by 5 plus 2. This is 2 by 7. So similarly we will find the probability of B and probability of C. Here PA is 2 by 5 plus 2, that is 2 by 7. PB will be 5 by 6 plus 5, that is 5 by 11. PC will be 1 by 2 plus 1 means 1 by 3. Therefore, PA prime equal to 1 minus PA, that is 1 minus 2 by 7 means 5 by 7. PB prime equal to 1 minus 5 by 11 equal to 6 by 11. PC prime equal to 1 minus 1 by 3, that is 2 by 3. Now we solve the problem one by one. Number 1. At least one question will be solved. That means we have to find the probability of A union B union C. Since A, B, C are independent events, therefore by complementation rule, we know that this is equal to 1 minus PA prime multiply PB prime multiply PC prime. And this will be 1 minus PA prime means 5 by 7 multiply PB prime 6 by 11 multiply 2 by 3, and this will be equal to, here we see that 3 2s are 6 means numerator 20 and denominator 77. 1 minus 20 by 77, and this will be equal to 57 by 77. Number 2. Here exactly 2 questions will be solved. Means probability will be probability of exactly 2 questions will be solved, means first question will be solved intersection, second question will be solved, and third question will not be solved. Or probability of first question will be solved, second question will not be solved, and third question will be solved. Or probability of first question will not be solved, second question will be solved, and third question will be solved. Exactly 2 questions are solved. And these are independent events. So we write here PA multiply PB multiply PC prime plus PA PB prime PC plus PA prime PB PC. If we put the value of these probabilities from here, then our problem will be solved. Now we solve the next problem. Problem is, a man speaks 80% truth and another 90%. While stating the same fact, what is the probability that they, number 1, contradict, number 2, agree? Let E denotes the event that first man speaks truth, and F denotes the event that the second man speaks truth. Therefore, probability of E equal to 80% means 80 by 100 means 4 by 5. Probability of F equal to 90%, 90 by 100, that is 9 by 10. probability of E prime means first man does not speak truth. Probability will be 1 minus PE. PE means 4 by 5 means 1 by 5. PF prime means second man does not speak truth. Probability of this will be 1 minus 9 by 10 means 1 by 10. Number 1. They contradict means probability of this will be probability of first man speaks truth means PE intersect second man does not speak truth. So contradiction. Or first man does not speak truth and second man speaks truth. Both are independent events. So this equal to PE multiply PF prime plus PE prime multiply PF, and this will be equal to PE means 4 by 5 multiply PF prime means 1 by 10 plus PE prime means 1 by 5 multiply PF means 9 by 10, and this will be equal to 5 multiply 10 here 4 plus 9 equal to 13 by 50. Number 2. Agree means opposite of contradiction. That means probability will be 1 minus probability for contradiction means 1 minus 13 by 50 means 50 minus 13 means 37 by 50. Now we solve the next problem. A bag contains 5 white and 3 black balls. Another bag contains 4 white and 5 red balls. A bag is selected at random and 2 balls are drawn from it. Find the probability of the balls being different color. Here we have 2 bags. Firstly, we have to select one of the bags. So for selecting first bag, probability for selecting first bag will be half. We have 2 bags, so this probability is half. Now first bag is selected and from it we have to select 2 balls of different color. Here we have in the first bag 5 white and 3 black balls. Means we have to take 1 white and 1 black balls. Means 5 C1 1 white multiply 3 C1 1 black balls out of 3 black balls by 5 and 3 8 C2 2 black balls. This is the probability for selecting 2 different balls from the first bag. Similarly, the probability for selecting the second bag half. This is half, and probability of selecting 2 balls of different color from the second bag. In second bag we have 4 white, so we take 1 white out of 4 white multiply. Here 5 red means 1 red out of 5 red by Here 5 plus 4, 9C2. Now required probability will be, firstly we select first bag, probability is half, and at the same time we will select two balls of different color from the first bag, and probability of this is 5C1 multiply 3C1 by 8C2. Or if second bag is selected, or means here plus mutually exclusive events, second bag is selected, this probability is half, and we select two balls of different color from the second bags, and for this probability will be 4C1 multiply 5C1 by 9C2. So this is the required probability, and we may calculate this and find the required probability. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.